Alright, think about building a house or manufacturing a product or planning a wedding. To plan a wedding, you'll need to first pick the venue, and then the next stage might be that you pick the caterer, and then the next stage might be you send out the invitations, and then at the end you're done with your wedding and you're off to your honeymoon. So there will be stages that require the previous stage to be done for you to move on to the next. So for example, you can't send out the invitation unless you've picked the food, you pick the venue. So there'll be stages that you need to go through to get to the end. So if we have some activities that can't be completed until the other activities have been completed, we can represent this in a couple of different ways. We can put it into a table. So here we show activity and immediate predecessors, meaning that these are the ones that needs to be done before you move on to the next activity. Or we can show them in what we call an activity network to show what needs to be done as we move forward. Let's jump right into this example here. So here we can see that activity A doesn't have anything before. So that's where we go. So starting here, so this is our start. And our activities, we put it on the edge instead of the vertex. Only the start and the end will be a vertex. So here A is where we start, right after we start, and then B, C, and D, as you can see, that A needs to be done just before. So that means we now go into 3 different ways, and one of them will be B, C, and D. From there, you can see B is the immediate predecessor of E, meaning the next one after B, let's go down this way, is going to be E. And you can see F is from C, so maybe let's put F here. And then G is after D, so G here. So F and G. And lastly, H has E, F, and G just before, so you can imagine these 3 are coming together. And then the last step is H. Now after H, there's nothing else, so this is the finish line. Alright, next thing we're going to look at is dummy activity. So dummy activity is not actually an activity, but a dotted line that we put on our networks to show that this requires for us to finish an activity before we move on. So for example, you can see the dotted line here. That's the dummy activity. And let's see what this does. So you start here, and then A is here, C is here. But then let's imagine you go to B. So if you go into B, and there's a dummy activity right there, this just means that you can't move on. You can't move on to D unless both A and B are finished. So even though B is not directly connected to D, because of the dummy activity here, if you were to go on this edge D, you need your A, so you gotta go from there, but as well as you need to come from this way as well, which is part of B. And that goes same for E over here. So if you want to go E here, you can see there's two arrows coming this way to get to E. So these both needs to be done, which is B as well as C here. So you can see this dummy activity shows that what needs to be done at this point so you can move forward. So let's see that in action. So here we have something like we had before, but now we can see there's a couple of immediate predecessors here. So let's see how that makes things different. So start off, we have A and B that has nothing. So that's going to be our two starting points. So start here, and one of them is going to be A, the other's B. So from here, we know C is from A. So from here, let's go up to here. This is C in a different color. And then D is from B. So let's make this D here. And then we've got E that has C and D as immediate predecessors. So we gotta think about how we are going to make C and D sort of come together to one point. But then if we look down the list a little bit more, we've got F that comes from C. So that means that we sort of have a line here. This has to be F. And then we have G that comes from E and F. So G is after F. So I haven't done this one yet, so I'm just going to circle this one. G comes from E and F. So G is sort of towards the end, probably. So I might put G here, make connect to like that. Then I'll just need to think about where I'm going to put E. So E comes from C and D. So if I make these two connect, that works out. And then make this E. Then you can see E and F are both connected to G now, which is good. Only thing that's missing right now is E connecting to C. So E is connected to D right now, but it's not connected to C. So the way to go is if we draw a dotted line here and then draw an arrow going that way. So that means after C, we go down the dotted line, go to E, go to the end of D right here, and then move on to E together. So this should be our network. All right, very last thing. Now we're given a network and we'll write down the table. So we'll start with our heading of the column. So first one should be activity. Next one should be immediate predecessor. Alright, so starting with activity A, we can see nothing before A there, so draw a little dash. And B comes from A, so B has A. C also comes from A. And then D is from B. And I'm gonna go this way so it's a bit easier for you to see. So E has coming from C, F. Now it seems a little bit confusing, so we've got to be careful here. So F is over here, and you can see that it comes from E, but also there's a little dummy line here that connects, and that's from C, right after C. So for F to start, we need to finish C as well as E. Oh, no, sorry. After C, we go here, and then we can start F. So that means that D has to finish. and then C has to finish as well. So it's C and D. And then G over here also sort of sprouts from this point, and this point is where we've got D and C again. So G is also C and D. And then H, A, B, C, D, E, F, G, H. H is over here. So this, if you look at this point here, that's where E and F comes from. So E, F. And then next one is I. I is just here. So that point there is just from G. And then lastly J, which is over here. So look at this point here. We've got H. And then we've got this dummy line here, which comes from G. So J is G and H.